here tomorrow.
What's up, Math Scholars? We're going to do part of the video. We're not going to do the whole thing. Some students want to just tune me out and keep working. That's okay, too. I just didn't think I could do the whole video in one class tomorrow. So we are on short periods for connections. That's why we're kind of not going to finish in one day. Okay, number 1. Circle yes, no, whether the following are polynomial functions. I do want to review with people watching the videos the 2 rules of polynomial functions. The 2 rules is rule 1, the exponents have to be whole numbers. And whole numbers are the numbers 0, 1, 2, 3. No negatives, no decimals. Rule number 2 of polynomial functions is all coefficients must be real numbers. And in general, pretty much everything is a real number except maybe a square root of a negative 4 or something. Coefficients must be real numbers. So the instructions are, if yes, then state the degree, type, and leading coefficient. If no, you don't need to answer what's the degree, type, and leading coefficient. So right off the bat on part A, I answered no, just because that 0.5 was not a whole number. So at that point, I'm done with that problem. Part B, all my coefficients are real. All my exponents are whole numbers, so I answered yes. My degree is the highest exponent I'm seeing, so it's a 3. That makes the type a cubic. I'll go ahead and put the type chart on here as well for all of you. I have it over my whiteboard, but people in the video can't see it. So the type is based on what the degree is. If the degree is a 0, the type is a constant. If the degree is 1, the type is going to be linear. If the degree is 2, the type is going to be quadratic. And if the type is 3, if the degree is 3, the type is going to be cubic. There's no special words from there on out. So if you have like a degree 20, you just call it a 20th degree. There's no special word for that. Leading coefficient on part B is where we left off. If I would write this in standard form, I would have to write this term first, and that would make my leading coefficient 12. Part C. It's going to be a yes. All those exponents are whole numbers, and all the coefficients are real numbers. The degree is going to be 9. There's just no actual special type word for that. It's just called 9th degree. 9th degree. And then the leading coefficient, if I put it in standard form, this guy would go first, so the leading coefficient would be that 0.8. Let me pull the video. Hello people in the video. I wanted to mention you will have a Polaris portion and a paper pencil portion again. So a lot of these types of questions will just be multiple choice type of questions in Polaris. Like what's the type? What's the leading coefficient? Is this a polynomial? This will be simple, quick multiple choice questions. Alright, synthetic substitutions, my favorite. Make sure you're showing your work nice and neatly and circling that answer so I can find it. You're going to put your 2 out here. That's the number you're going to be substituting in. My setup would be a 1 for my x cubed term, an 8 for my x squared term, a -7 for my x term, and a 35 for my constant term. The hardest thing for people is including those negatives, so make sure your 7 is a negative, and also remembering how to start. People I've seen start these incorrect. You want to take this 1 and drop it. If you don't drop your 1, your calculations will probably be messed up in the end. Alright, 1 times 2 equals 2, and then we're going to add straight down. 8 plus 2 equals 10. 10 times 2 equals 20, and then we're going to add straight down. -7 plus 20 is 13. 13 times 2 is 26, and then I'm going to add straight down and get 61, and that's the number you'll circle. Now I did mention use direct substitution to check. It gives you practice with direct substitution, but it also allows you to check your answer. So you just basically are finding f of 2. You're putting a 2 in everywhere you see an x. And I would just utilize my calculator at that point and just verify that you get 61. But it does check out. It works. Alrighty, number 3. It's a -1 we're putting in our little box. Now this one's a little tricky. It does require a 0 in our setup. 5 is the leading coefficient for the x to the 4th term. 3 is the leading coefficient of the x to the 3rd term. -4 is the coefficient of the x squared term. And then at this point you're like, uh-oh, I don't have a linear term, a term with just x to the first. That's going to be your 0. And then you have a negative 20 at the end. And so just check your setup that you've got a negative 4 and a negative 20, and you have that 0 placed correctly. We're going to drop the 5 to start, so you're going to have 5 right here. 5 times negative 1 is negative 5. Add straight down. That'll be a negative 2. Negative 2 times negative 1 would be a positive 2. Add straight down. Negative 2. Negative 2 times negative 1 is positive 2. Add straight down. And then positive 2 times negative 1 is negative 2. Add straight down. Negative 22. You can nod your head if you got negative 22, because I haven't actually done this problem yet today. Perfect. You can use your direct substitution to check. If you do go ahead and put that negative 1 in, just a reminder to everybody at home that you need parentheses exactly like that in the calculator, or your negatives won't calculate out correctly. So I always use parentheses around my negatives when I'm going to be utilizing exponents. That is, what I just wrote on the board is exactly how you would want to type that into your calculator. And you should get negative 0.2. Alrighty, number 4. We just learned this one yesterday. You can use the rainbow method of foiling. It's just kind of a little bit longer than a normal foiling problem. Or what I'm officially recommending, because it organizes the work way better, is the box method for something this big. I would set up my x and my 8 on my side of my box that I have 2. That's my binomial. And then I would do my 5x squared, my negative 3x, and my 10 along my box that has 3 sides. That's my trinomial. Alright, let's fill out your boxes. This box will be 5x to the third, because an x times an x squared is x to the third. This box will be a negative 3x squared. This box in the upper right will be a 10x. Down here it would be a 40x squared. Right here it would be a negative 24x. And right here it would be an 80. Now at this point, finding my like terms is just so easy with using this box method. They're normally going to be diagonal, which they are. So we do want our final answer in standard form. You want that 5x to the third to be written first. It has the highest degree. And then you can add up the 40x squared and the negative 3x squared to get 37x squared. The negative 24 and the positive 10 is negative 14x. And then we have the 80 last. Can you guys nod if you match me on this? Perfect. Thank you. Did everybody get a chance to check number 4? Okay, we have like 6 minutes left. Let's try to get one more problem in. These periods just fly by on Wednesdays. Number 5. I'm going to pause the video and get myself a little more workspace. All right, on these, you have 3 binomials being multiplied. We just learned this yesterday as well. You can only do 2 at a time, so I'm going to start by foiling these first 2. X times x is x squared. X times 1 is 1x. Negative 2 times x is negative 2x. And then negative 2 times 1 is negative 2. Don't forget to combine your 2 middle like terms, because that will make a trinomial for yourself. So there's our trinomial. Don't forget, we still have that x minus 8 as a binomial. And then that's where I'm going to probably finish this off by drawing my box. That will allow me to, you know, multiply that trinomial and that binomial a little more effectively. So here goes drawing my box. A 3 by 2 box, like it was in the last one. We'll have an x and a negative 8 along the one side. An x squared, a negative 1x, and a negative 2 along the other side. Okay, let's fill it in. We'll have x cubed, negative 1x squared, negative 2x, a negative 8x squared. Ooh, beware the double negative here, positive 8x. And then another beware of your double negative, positive 16. How does that go? We're going to add up our diagonal boxes for our final answer. In standard form, it will be x to the third minus 9x squared plus 6x plus 16. Well, thanks for joining me for the first part of the video. How far did we get? What number was that? Number 5. So join us in our next episode for the rest of the study guide, all right? Hope to see you all at a study party on Thursday after school till 3:10 or Friday morning at 6:50.